Today we're going to talk about thermodynamic processes. Thermodynamic processes occur when work is done on or by a system, when heat is added or removed from a system, and or when the internal energy of a system is changed. So we're going to talk about when these things could occur and what processes they could occur by. So the first process is an isovolumetric process. Now, this is also often referred to as isochoric. Okay, so if you hear that, it's the same thing. In our class, we're going to refer to it as isovolumetric. Another word for it is isometric. Okay, so let's look at this word, iso. Okay, that means constant, and then volumetric would mean volume. So it makes sense that the isovolumetric process occurs when there is a constant volume. When this occurs, there is no work done on or by the system during this process. And the reason for that is if it's isovolumetric, okay, remember work is a force times a distance. If it's isovolumetric, no distance is changing, okay? And if no distance is changing, then you're going to have zero in for that term and you're going to get zero for the amount of work. When does this occur? Well, it occurs when the fluid is in a rigid container, okay? A container that's not going to change its shape. So some examples, the sun heating up a car with its windows rolled up, okay? And also heating up a fluid in a pressure cooker, or placing a tin can in a fire. Now, eventually the can is going to expand, but it's a fairly rigid container until it expands, okay? So this is considered isovolumetric as well, okay? That's our first process. Okay, and the key things here is it's a constant volume, a rigid container, and when this occurs and it's isovolumetric, the total work done is zero. The next thing we're going to look at, the next process, is isothermal. Okay, well, again, iso means constant. Thermal, okay, that's temperature, so it's a constant temperature. So an isothermal process occurs when the temperature does not change. Okay. When this happens, there is no change in internal energy, okay? And it happens when it's a gradual expansion or compression. Some examples, a phase change is isothermal, okay? So if you're melting an ice cube, that's an isothermal process, and the change in internal energy is going to be zero. Boiling water, another phase change, okay? It's isothermal, and it's going to have the internal energy change of zero. If you are slowly inflating a bicycle tire, okay, again, it's going to be at a constant temperature, and this might be a little bit difficult to understand. It's not quite completely constant, okay? If we slowly inflate the bicycle tire, the temperature is going to go up a little bit as we inflate. We're going to do it slowly, so we're going to kind of let the temperature come back down, and then we'll inflate some more, and then it'll come back down, and then we'll inflate some more, and it'll come back down. And over time, this process is having roughly the same temperature, okay? We call that quasi-static. Quasi-static, okay? So this is another example of when we're going to go ahead and say that this is isothermal because over time the change in internal energy is going to be zero. The next process is the adiabatic process. This occurs when no heat is added or removed. So Q is zero. Okay, we're not adding or removing heat. Okay, it occurs when there is a rapid expansion or compression. So unlike the last one where it's gradual, this is very fast, okay? Examples would be inflating a balloon with a helium tank. So you inflate that balloon quickly, okay? Or rapidly compressing a car's piston. Again, keywords here, rapid, okay? And that means it's adiabatic, and that means that there is no heat added or removed to the system. The last process we're going to talk about is isobaric. Okay? Again, iso means constant, so it's a constant pressure this time. Okay, barometer measures pressure. Kind of remember it that way. Okay, constant pressure. And pretty much all the situations that we're going to encounter, most of them, okay, are going to be isobaric. Why? Because we're going to be doing things with containers that are open to the atmosphere. And if it's open to the atmosphere, it's at atmospheric pressure. Okay? So let's go ahead and look at this. Work is equal to the pressure times the change in volume. And I forgot the little change in there. Okay? So how do you get this? How do we get this equation? All right. Well, work is equal to force times the distance times the cosine of theta, okay? And pressure is equal to force over area. So what we're going to do is we're going to first say that we're going to have this be in the same direction, the force and the way it moves, so that we can get rid of that term because it'll just be 1. And then we're going to go ahead and rearrange this equation. We're going to solve it for the force, so multiply both sides by the area, okay? So force is now equal to pressure times area. Substitute this in here, so work is equal to pressure times area times a distance. Okay, the volume is the cross-sectional area multiplied by the height. So this is the volume. So work is equal to pressure multiplied by the change in volume. And that is how we derive this equation. Okay? Examples of an isobaric process. Again, things that are open to the atmosphere. So if you boil water in a pot without a lid, it's open to the atmosphere, it's happening at atmospheric pressure. Okay? Again, if you have an ice cube and it's melting in a glass of water, that's open to the atmosphere, so it's an isobaric process. We can use this equation.